Welcome everyone. This is going to be a fairly quick presentation on multiplayer replication O3DE. This presentation is sponsored, I guess, by SIG Network. We have a few slides. It's scheduled up to 1 hour, but it shouldn't take that much. I'm going to leave plenty of time for any questions and answers. If something burning comes up, you can ask in between as well. So at the core of multiplayer replication is something called delta replication. And I'll step back from the beginning what the context is and so on, so that once we get to the idea of delta replication is, it'll be pretty clear. But in general, the idea is you only send what changes. So in the larger context, anytime you create a project in O3DE, you get a game launcher and a server launcher. This is your client and the server, and you can, for example, get the O3DE-multiplayer sample project. You can create a server using plus host command. You can have a client that you would join to that using plus connect. Plus connect actually takes an IP and a port address if you want as well, so you can connect it locally if you don't specify any parameters or remotely. So that's the basis. But once you have game and launcher, if you just launch them as this, you do not do anything special to your components, you're not going to see any replication going on at all. There's not going to be any synchronization between server and the client. So let's take a look what's going on there. Let's say you have a game launcher and a server launcher, and you have the same component present on both sides. Components by themselves do not have any network abilities by default. So what you'd have to do, you have to add another component on top of that. Sometimes this concept called like a head crab. And the idea is that your network component talks to the non-game, non-network component in some way. And that way they pass information back and forth. And the actual communication between server and client really occurs between those network components. And in O3DE, the replication is done over UDPs, which is the user datagram protocol and so on. This is mainly under-level protocol by design. Now, this presentation, I'm not going to go too much into actual transport layer. We're going to stay on top of the transport. Transport layer is AZ networking. That's something you can look elsewhere. But we're kind of starting at the game launcher on top of UDP. We are working with components. So the next we have to look at is to how do we actually communicate between a regular component and a network component. So let's say we have an entity. It might have some properties. Components may have a whole bunch of properties. For example, if you have a transfer component, it will have a position, orientation, scale, and so on. And as you working on your project, you have to decide which of those properties you actually need to replicate. Maybe you don't need to have them all be serialized across between server and host. So as you build that out, you would add your network component, and you might decide that this particular property will control the other ones. For example, network transfer component replicates, as you would expect, the position, rotation, and scale. And your network component will be communicating with the non-game, non-network component through various means, be it eBus, event pointer, JAK pointers, whatnot. So now that we have this kind of structure laid out in general context, let's see what happens on the kind of sending side. Let's say you have a whole bunch of components. These are network components. They have some kind of data in them. Now, by default, if none of them change, nothing will be sent. But let's say at some point, one of them have changed or two. Now, what would happen behind the scenes is that these components will get marked as dirty, and the entity will be marked that way as well. And then on the next kind of server update tick or whatnot, network entity manager will come in and we'll find like, hey, I have these two entities that are ready to send out the updates. So it will pull them up, and it will place those changes into packet of entity updates. And entity updates will just kind of stuff the reference to which entity this change coming from, to which component, to which property is changing in the value. And you're going to have multiple of those kind of stacked up. Once you have this packet ready, it will get sent out. And every server frame or so, you're going to have multiple of these packets being kind of sent out. So now we can take a look what's happening on the reverse side. What's happening, I'll say, on a client when we get these updates. It happens pretty much in reverse order. You look at the entity updates packet, you see which entity this change is coming from, what the component it's coming from, what which field of the property of the component is coming from as well. And if you unpack it, you begin to look, all right, let's look on the level or that you're present on your game, where the entities are, where the components, and let's take a look at find those entities and update them as such. And finally, once you have your update to another component, you will then have to find your game components, usually be in the same entity, and you would pass the information along and shove it into the regular component. So that's kind of general overview kind of the structure where we look at. And now we can look a little deeper at actually happening into delta serialization specifically. So we're going to first go back and to see what happens when you serialize from existing world entity into an update message packet. So let's say you have an entity, and the entity by default requires network binding component to be a network entity, and then the rest of your components will be just kind of any other components you might want to. So let's say a few of those components have registered to change, okay? So we have 3 components changing. On the next tick, anytime when the server is ready to process these changes will be used to this particular serializer on the multiplayer jam. And as it begins to process the entities, it will start building an update message. And so what it will do is that it'll grab the first component that it sees changing, it will shove it into update message. And additionally, it'll start building a particular like a mask, but really it's got a list of bits. So in this case, it'll be indicating like, hey, this first component changed, so I'm going to mark that bit as positive one. Same thing happens to the second component, and now we have a little bit more payload to the update message, and the bits have additional 1 as well. So that means first ones I go on have a payload coming in for that change. Now the next 2 have no changes. So there's nothing to save, there's nothing to send, but we'll still mark them as 0 in the bits changed. That way we know on the opposite side we can skip that over. And then the last component does change, so now we have 3 component payloads and update message plus some additional bit masking. In reality, when you send this across, there's not going to be any empty space in the payload. It's going to be nicely compacted. You're going to have 3 components, and you have bits coming out on the other side as well. Sometimes these are called like dirty bits, indicating which data to apply for that. So for example, this is happening on the reverse side. Let's say we're coming from server to client, and a client now we need to unpack this data and apply it. Well, what you would take a look is, let's say you have a client entity now. It's the same entity that's like logically and conceptually the same both server and client. And now let's see how this payload will unpack it. So first we'll look at the first one. This is your component data, and the bit is true, so we write it in the first component we essentially see. The same thing happens in the second one. It's still there, still true. Now the next 2 zeros indicate like we need to skip those other components or whatnot. And the last one, we know how that goes to the last one just because of the way we saved it in bits. And so together that forms your update message. You might have different sizes update message. You might have 1 or 2, and your bits particularly might change depending on which components that comes from. So that's the basics of delta replication. You're just sending just what changed, and you kind of save in a special way how you want to do it. So different projects and games approach that differently. Some of them would replicate the whole world, and you have like this large, very long list of bits indicating literally every object. Like back in Quake time, that's what they would do. They would just write 1 if they're writing for a property, and include the payload. They would write 0 if you're skipping a property, and just a bunch of zeros until you hit 1 again. In case they were compressing everything. Whereas a multiplayer jam doesn't save the whole world. Instead, we're just going to do 1 entity at a time. Additionally, some game might decide to send like 1 byte of dirty bits information, and then the rest of the payload with different approaches. But the concept is the same. You have the payload, and you have some kind of bit masking to indicate where each one is being applied. But let's see how this applies to the idea of actual component messages and reverse rotative design in multiplayer jam. So in multiplayer jam O3DE, we have 3 different roles that's worth understanding here. One of them is the authority. That's your server side. That means this is the entity that owns the object. It can write, have access to the data. The counterpart to that is the client, and the client is essentially mostly just read-only. And autonomous is a special special little type specifically assigned to player entities a player owns, usually with their character controller. And the difference is if you have a client role, you can read a value, but you cannot assign to it. Whereas if you have authority on the entity on the server side, you can both free to be also get a special controller subclass, additional object inside your component you have access to, and that guy have a specific ability to write to a value. As mentioned in the previous slide, you also have an autonomous role. And that one is very similar to server side, but it's on a client. This is specific only for player objects. So usually be replicating values from a server to a client. But in this particular case, this is your player producing input. And so you need to send that input back to the server. And so that's why you need to be able to change the value. So let's see how this delta replication applies to actual network components, like at the level of code generation. Outside of networking, we're kind of familiar with how game components created. You can create them in C++ code. You might have different information to it. There's different ways. Sometimes most components can derive from AZ components. Some components in Atom classes, they have more advanced approach, but that's the general basics. Now, networking components start from different structure. They actually start from an XML definition of a file, and from that it creates the my component portion, which is your read-only view, which is present everywhere, and additionally creates the my control as well, which is the write ability. It's going to actually change the component data. And at the same time, usually you would have to register components manually by going to your AZ module. You would go to M descriptors and you can add them one by one manually. With networking code, this is done over one call, and then automatically code generator will add those components for you as well. And you just need to call those two functions once in different locations and you'll be done. Now, additional element is the code generator creates just the base, which gives you the basic functionality of replicating data and delta replication, all that. But if you're looking to add your game logic on top of that, you would have to inherit from those bases in XML. Let's take a look exactly how to do that. But the idea that the base classes are the ones that give you like the groundwork, and then you would subclass on top of them to provide your own logic. And it's up to you. The idea is that if you're looking to add additional client logic, that would go into my component override. If you're doing server stuff or you're doing like player control objects on the client, then you would need to override controller. And we'll see that in a moment. Like for example, as an example, if you take a look at multiplayer jam, one of the basic components is network transfer component. That was the definition for XML, and from that you will get component base and controller base. And as network component needs to do work on the server and the client, so it overrides both of them. First, we can take a look at the XML structure, kind of a brief introduction to it. So first with XML, so you start by defining it as a component. You would start by choosing the name for it. So you would have a field name, and this really can be anything, but it's up to you. Generally, with network something component works well. It's because we're generating C++ code behind the scenes. You kind of need to specify the namespace as well. You could multiplayer sample if it's a project. It could be a gem name. Now, in this case, network trans component has work to do on a client, so it needs to override component. Now, override means you don't replace it. It's more like you're inheriting from a base class to add something on top of that. At the same time, you also need to do something on a server, so you will need to subclass the controller additionally as well. And the last critical portion here is to provide the path to the header file of the subclasses you're going to write on top. And so this particular path is relative to the path on the code source path of your jam or project. So that's the basic, that's going to define like the basic structure component. And then additional after that, this is where you can choose to add fields. Now, when it comes to delta replication and all that and little dirty bits, that has to do with network properties. Those are the properties you define, like these are properties I want to replicate. Like we saw position before, and this is you would define the network transfer component has to replicate a position. You might have some initial values. And inside init and the type here, this is all C++ code, which will be just kind of copied from this XML, place into the code generated base class. And the less interesting part is replicate from replicate to. For a gem, authority is your server, client is the client, and autonomous is your player own objects on the client. But you can also choose the direction of replication. And most of the time, it's really just server, authoritative server to the client. But it could be additional things where you go from a player-owned client to the server. But by far, 95% of the cases is going to be authority too. So what are you going to get from this XML into code-generated code? In the build folder, you're going to get, in this case, is going to be the network transform component base.h and .cpp. And so these 4 lines, for example, is one of the generated code you would get. Since you provided a field name code translation, it will create a getter and also get a previous for the same value. Now, get previous is going to help your thing because oftentimes you want to be able to interpolate from previous value to the current value. So we provide a history for that field. And translation add event is a way for clients to sign up for changes. For example, if you want your client object to listen when a server presented it with a new value, you can sign up using a Z event handler in this case. For example, here's a snippet of code from network transfer component. On pre-render happens pretty much every frame. And it says like, hey, if I don't have a controller, if I'm a client and I'm not a player owned, that means I just need to obey what the server tells me in terms of location, position, rotation. So in this case, you can see it just says get rotation. Now get rotation is your getter from the base class that's generated by XML. It's the same thing, get translation as well. That gets you the latest value that the server sent to the client. So this is the read-only client view. At the same time, you will also get a controller class defined for you. Now it will have getter methods just the same, but critically it will have ability to have a set to the value. If we set to modify translation. For example, if you have your network transform component controller, which is a bit of a mouthful, but essentially means it's some kind of owning object that can change the component values. In this case, it's signing up on a server, for example, to listen for changes of movements of an entity. And if it does, it will get them out and set the translation on the field. So now we're going to went through that. Now we can reconnect back to the little bits that fields that change. Because aside from these base classes, we actually get a whole bunch of other structures generated for you. One of them is a special enumerator. So what this enumerator does is that for every network property that you describe in XML, it will build out this class, enumerator class, which the system will figure out which property is changing when. So this is when your dirty bits, for example, could be coming in. So if you have 11001, that means first one will be rotation changes, translation changed, but maybe skeleton changed, reset counting changed, but maybe parent ID. So for example, when we serialize a value, in this case, this will be serializing authority from a server to a client. What we actually do is that we use that enumerator value under translation underscore dirty flag alongside, in this case, you will send it to the client. It'll be the payload, the value of it, and this would serialize that value, specific ID. So in that case, we don't use any component IDs. We can try to compress the value as much as we can to the ID. As opposed to component ID, would be like 64 bits. In this case, it could be just a couple of bits. Now, on the other side, when this arrives, this is where you notify the changes, and this is where you get to apply it. So for example, in this case, you would again listen to that bit flag and be able to tell like, hey, this translation just changed, so that's when we can get the value out of it and signal it, and that will be replicated to your client side components so we can correctly apply them. And that was that. That was a fairly quick introduction to what delta replication is. So as the final moment, delta replication is really converting your components into this structure where you can optimize which components are changing, and when you write it into serialized packets, you will specifically mark out plus the payload plus the dirty bits. For additional review, we have a number of resources online, specifically tutorials for multiplayer. There's one that starts how to write your first component, and it covers things like how to add network properties and remote procedure calls to your component. Other than that, I'm ready to take any questions you guys might have.
Nicholas here. I have a question in regards to the XML component. Could you choose to, okay, so first of all, when you generate an XML component through the auto components, I believe, process, it generates automatically C++ class on the fly for you. Now, I've realized that those classes are thrown into the build folder. So how will you do, if you want to, how will you change? Do you insist to change stuff through XML continuously? How do you work around those C++ classes being generated? Do you attach them in your code editor or not?
So this is network transform auto component header file that came from XML. And the first big block of text, this is your stub to get started. So this is how you start your client side, component side, and they have a controller. So these guys is what you would take over, copy into your files, and build on top of. Now the rest of the code provides, minimize some of these classes. Anytime you see the base, that's the base functionality that you would build. In order to use that, you would subclass it. So if you take a look, go back to here. This is the base that you inherit from, and network transfer component is what you're using. So for example, if we jump back to network transfer component and we go back to the header, this is where inherits component base. And then example pre-rendered, this is where it happens over tick, and then you can make changes. So it depends what changes you make. If you're just looking to use properties, set them, get them, and apply them, you don't need to modify any base classes.
Thank you. Second question is follow up on this one. Do you suggest we build this auto component structure or the extension classes of these auto component classes into, let's say, server launcher when we talk about network components? Where will architecture be the right place to do that? Let's say I want to, for example, I want to acquire data from a backend service, right? And I want to make that data available for, I don't know, a component that has rotation and translation, and I want to pass that on. What would the appropriate architectural structure be for that specific example?
For component work, they need to be present in the same way, in the same setup on both client and the server. So generally you would see them in part of your static library. For example, for multiplayer sample, this belongs to multiplayer sample.static, and you will see these lines indicating that we're processing the outer components and generating the output from them. So they generally go into a static library, and then you link that into your multiplayer gem. Now, what goes into the client and server, that kind of determines by the aliases. But in general, if it's actual game replication, it's to go both in the client and the server. So they're present both. And so again, if you're on a controller, you will be able to do specific server code. But actually, just remember, there's one additional thing that can help you. If we go back to component base has another base class, which is a multiplayer component. This is your most basic level for multiplayer. And one of the things it has is that it can ask it what role you're in. And for example, these roles could be autonomous server, it could be a client, it could be, autonomous client rather, an authoritative server. So if you're inside a controller and you want to know, like, am I on a server, then you can ask it if authority or this particular call. And if you're looking to be on a client, like inside a component, you're pretty much always on a client. Well, it's not true. A client without a controller, a component without a controller is on a client. So let me see. So for example, here network transfer component is asking, do I have a controller? If I don't, that pretty much means it's on a client. There is some potential case of multiple servers scenario, but in the simplest one single server, multiple clients, you would have component without a controller as a client. And this is where you can choose what I'm doing on the client. And the server counterpart to that is, let me see. So this is your controller. This is something that can live on a server. And one of the things it does is that it listens for transform changes. Anytime it moves, it gets notification. This is the it sets it. And if you jump to the definition of this set, it will actually jump to the build location. And this is your controller base actual sets behind this. Does that help answer?
Yes, thank you.
Also, going back briefly to delta replication, this is where you can see those bits coming into play again. When it modifies, it specifically notifies which part has been modified for this field. Rotation dirty flag, which is just 0, 1, and so on, it builds up. And behind the scenes here, it also marks the parent as dirty. So if the component changes, it also modifies the entity as being dirty, and so on and so on. Most of the time, you don't really need to worry about the base classes. I think it'll be just useful just to know that you can look them inside Visual Studio, and just the header file is pretty good. Like for example, these portions. So this is a controller, right? Yeah, we're inside a controller, so that's why it has both the getters and the setters. So kind of this information should be more than enough to work on.
It sounds like you don't ever modify the generated code and you don't ever check the generated code in. It's meant for you to derive classes from. And all of the interesting stuff is you put in your derived classes.
Correct, yeah. The one time you do want to go to your generated code is when you first create a component. Then it's really helpful to be able to copy this code out to get started on. And if you, for example, if you disable enable overriding component or controller, this comment will change. So then again, it will be easy to go back to here, copy it out. And after that, you can mostly ignore it. Just kind of know that there's getters and setters for the properties by the name you're giving them from XML structures. And that's it. So if you have rotations, you can find get rotation in the base class. And yes, you don't need to ever worry about this. Build files will be generated at build time, not at CMake configure time, but specifically at build time. So when you first check out a project, you have to build this particular static library to get this file generated.
Data types, let's say AZ, STD, string, and stuff like that. Unfortunately, documentation doesn't have much on them right now. But I've seen, yeah, stuff like that, like uint8_t. What's the difference by using STD standard or versus AZ STD, and what's the pros and cons between those two?
So stepping back, this XML does not validate those types at all. It basically just takes what's there and places it into the code gen as is. So it's possible to just write a bogus type here and get a code that just will not compile. So you need to be sure that the stuff you're compiling here actually is a valid C++ type. And if it's some kind of unknown type that's usually not available, you might have to use an include element here to provide information there. But aside from that, from my studio not. As far as networking context goes, generally you want to use a smaller type, as quantized type as possible. So for actually, like in this case, we don't even use AZ entity ID of networking. We have our own separate net entity ID, which is a bit smaller. Well, it used to be smaller, and it's incremental. It increments from 0 to 1 and 2, so on, as opposed to trying to obfuscate and build more like a small GUID. Another interesting thing is to quantize the values whenever possible. So let's see, do we have? I think I have an example of that. And multiplayer sample for. Aside from network properties, you also have network inputs. The inputs is if something goes from a player object to the server. In this case, you might see like weird types like stick axis, whatnot. And it's really implemented inside this header file, multiplayer sample types. And these are quant types. It can be like a float, but networking, you're trying to compress everything as much as possible. So this is actually a special structure from AZ networking library, which is quantized values. And this allows you to define what's your minimum and maximum. So as opposed to sending all 4 bytes for a float, you might decide to compress it down to 1 or 2 bytes instead. So I wouldn't so much worry about if you're using AZ STD or not. I would try to think what's the smallest data type that can support just information you need.
When we have methods such as deactivate and all that, what's the equivalence for a network component, like when it's terminated?
Good question. It's almost the same. There's only one small difference to it. Instead of activate, there's on activate and on deactivate. I believe we hide the actual activate behind it. Other than that, the controller has the same thing: on activate, on deactivate. One nice thing, because all these classes, all these files are part of the build system, you also get your visuals to IntelliSense as part of that setup as well. So for example, you can see like, hey, who's calling this? Well, it actually gets called by activate and just passes some additional. But as far as types go, I think quantized value is very useful, and you can see example of that in multiplayer sample project. One additional thing that I like about XML structures is they can cut out a lot of reflection to the editor. Instead of setting up your properties manually, you can actually just declare archetype property, which exposes something to the editor for you, and you don't have to write all that fancy magic. Because if you jump to, for example, to our touch component here, and you look at the reflect set, it's very simple. There's nothing there. That's because all the all the hard work is done by the coordinator class here. All this stuff you've seen here, this is generated from XML. And you can scroll it pretty fast if you don't need to do all that work, you just define stuff in XML.
So practically gems are modularization of your code for specific tasks. What's the actual purpose of the server launcher? Is that something you 100% sure it's going to be executed autonomously only on server side? How do we know when we launch how things are progressing? And
good question. I think there's actually work in progress. What's on my list, which just adds ability to poke at the registry to ask if you're a game launcher or a server launcher. But that's all. You really will need that before you call the host command. Once you call host, that's when you know yourself you're a server now. Now, one of the things that happens on the server launcher is actually number of setups actually disabled. For example, ly shine, the user interface gem, is completely disabled. Additionally, when you gems have ability to declare if it belongs to server or not. For example, these 4 lines, very similar present to all the gems, and they can define which of the targets they created go to which folder. So any gem can decide, like, I'm only a client, I do not present anything to the server. So it's up to designer of each gem. In this case, for example, multiplayer sample, this is your target, and you can choose, does it go to every form or not. So you can actually choose selectively which subset of gems gets used, either client or server or not. So for example, if you're looking to build code, you do not want it to be exposed to the client for security reasons, then you basically remove this line out entirely, and it would not be appearing on the server in that case. Well, you still need to make sure you don't ship that part to the client as well. But if you build a monolithic, that should be entirely avoided. So that's the way you control it.
Yeah, to be more specific about this, every single gem chooses those aliases for any target they make. A gem could output hundreds of DLL modules, and the aliases are how it specifies which of those DLLs it makes is loaded by which type of application. It also means that if you're making a game project, it doesn't have to be a gem. Like the actual game project itself can choose to make a different module that gets loaded in the server than the client if it wishes to keep code private.
Yeah. You could build a multiplayer sample client, for example, and you have additional target multiplayer sample server. And then here you would define multiplayer sample client goes to that client, the other guy goes down to that servers, for example. All right, you throw no more questions. I think we can end it. Thank you for your time, for stopping by.
I had just one question, which is just about the sort of number of network properties you can have in a component. Do we split those update packets at all? Are they all guaranteed to happen in the same update? And then are there any kind of gotchas or anything we should pay attention to?
There's a maximum how many properties you can have, at least per packet. Because at some point, once you packet gets too big, doesn't fit, we'll have issues. I don't remember offhand what the limit is. I don't remember if we fragment the packets. We do support fragmentation to some degree, but for really large entities, it might be a problem. I think this is where computation comes into play. Like if a component gets too big, it's better to break up component itself as opposed to deal with packeting and fragmentation of packets.
Yeah, that's good advice. I was just kind of curious if we end up fragmenting the packets and the update mechanisms support that, but and also when might you notice that? But I think I can just try and look that up in the documentation.
Previously on your presentation about UDP connection,
Right.
Why is it just UDP, or are we going to have TCP capability as well? And why the one and not the other, if that's the case?
Yeah. So what we're going here is that we're going for maximum responsivity of a client to the server connection. So when something changes in the client, we want to know as quick as possible to the server and back and forth. And anytime so the reason UDP is great for that is because it doesn't care about the ordering, doesn't care if it's arrived or not, doesn't have to wait until the acknowledgement from the other side comes in. You might drop a few packets here and there, but in a distant connection, it's not going to be a problem. In that case, 95% of the time, you're going to get the packet as soon as possible. Another thing that happens is that with TCP, if you happen to lose one packet in between, like the whole pipeline just stalls entirely, has to wait to ask the other side, hey, give me this packet, I did not get any yet. And it will wait for that thing to come back before it sends everything else that might be waiting for it. And the TCP, that can lead to fairly big hiccup. And like if you're just serving websites, you don't notice that, that's fine if you're waiting for half a second. But if you're playing a game and you're pressing forward left to duck some kind of damage, something coming at you, then you want that to happen immediately. You cannot handle those little hiccups in TCP structure. So yeah, that's why we're using DP for that kind of application. Now, if you're doing something that doesn't require like very responsive setups, like maybe like Serialization or something, then TCP compiler works fine. But then you also don't need to worry about, for delta replication will still apply to TCP, you still want to reduce how much you're sending. But if you don't need something like super responsive, like a shooter, let's say, then UDP is not necessary. But if you are looking to be a competitive reactive game, then it has to be UDP.
The network layer does allow you to transmit things reliably, right?
Yes, reliably, but it still goes over UDP. And even half the time, we'd even send things unreliably. Like, for example, this is the send client input. This is when you're sending what things you've pressed, whatnot, from a client to the server. You will notice that it's actually unreliable. But what we do behind the scenes is that we send the current input plus 7 more, plus 7 previous inputs. So in that case, you can lose, let's say, some of those, and you can still reconstruct the input on the server. So there's multiple ways of approaching that. Now, we do support reliability, but again, reliable means you're stalling the kind of the throughput. So most of the time, it's better just to say that unreliable and maybe send some a little bit of extra data every time.